Assalamualaikum warahmatullahi wabarakatuh and good day everyone. I hope everyone is in good terms. So I am Dr. Siti Nora Fidawin Yusuf and today is we meet again to discuss soil classification. So we know that in soil mechanics we concern with the particulate materials which is soil that found in the ground and it is not cemented and not greatly compressed. So we learned in previous chapter soil basic properties that we can derive some void ratio, porosity, degree of saturation and so on. So we know that these particulate materials can have gaps, have voids, and it is not a homogeneous material. So it has wide range of particle sizes, also different shapes and different mineralogy of state of the soil. So it is not very appropriate if we want to classify the soil in details. I mean, one particle to another particle. So usually what we do in geotechnics engineering is to classify the soil by using observation and also classification system. So let's see what it's all about. So this is the outline of the courses for this chapter. So first we have introduction, some purpose, soil identification in field, and laboratory testing. Uh, and I will highlight two classification system which is USCS and also H2O. So what is soil? Okay, so soil is discrete particles which has varying in sizes, in shapes, and also its mineralogies. So once geologists said that soil is a product of the past surface processes, yes, we learned this in the introduction of soil mechanics. And pedologists said that soil represent currently occurring physical and chemical process. Yes, this is also true because soil keeps changing its state due to the weathering process that include the physical, chemical, and some other process. And for ours, as engineer, we see the soil as a material that can be built on, built in, built with, and supported. So we want to use the soil. For engineers, we want to use the soil, and usually any soil that available inside has to be used. Uh, and we understand that soil is differ compared to other engineering materials such as concrete and so on because of the varying of in sizes, in shapes, mineralogies, and so on. The heterogeneous material. And we understand that we have a very little control over the soil properties. So that's why it is important to understand the soil classification. So this is one picture showing that variety types of soil. We can see the darker color of soil, maybe it has mineral or organic in it, light color, and then some is very fine soil, but some with the bigger grains of soil. Okay, so this is some of the soil grain shapes, and in general, soil can be classified into two types of grain, coarser grain and also the finer grain. And coarser grain usually sand bigger than 4 millimeter, and smaller than that is clay. Can be smaller than 0.0063 millimeter if I'm not mistaken. And the shapes is varies. It can be bulky shapes, especially in sands and gravel. It can be angular, subangular, subrounded, or rounded, or flaky or needle shapes, which is mostly found in the clay. And later we go further, we can see more about clay and silts. Okay, this is a soil particle size comparison. We can see the comparison between the sand, silt, and also clay. So the finer grain of soil is usually silt and clay because it's smaller than 0.05 or smaller than 0.075 for US standard. So this one is BS standard. And then sand particle is in the coarser grain soil category. So coarser grain soil can be sand, and much more bigger is I think gravel, cobblers, and so on. Much bigger size compared to sand. And here is some figures about this is I think gravel, okay, sand, clays, different type of clays and silts. This is the standard that I mentioned just now. We have in general worldwide we have USCS, American Standard Size. So anything that smaller than 0.00075 is considered as finer grain for USCS, but for British Standard BS, anything that's smaller than 0.0063 millimeter actually is considered as a finer grain. So this side, the clay and silt is finer grain, and sand and gravel is considered as a coarser grain. So the soil particle size, even though natural soils are a mixture of various size particle, but we can find the predominant sizes. So we can later classify them as a poorly graded or well graded. And we can see more this gradation condition using the sieve test analysis later. So this is soil structure. Just want to highlight. There's a lot of it, but just want to highlight two conditions. Flocculated means kind closer to each other, or dispersed, getting further from each other. So silts, silts and also clay is kind of siblings. So sometimes it is difficult to differentiate what is silt and what is clay. So this is some of the properties or the condition of the silt. So it still can feel gritty feel. So usually in sand, it easily defined as a gritty feel. But in silts, we can slightly also feel the gritty due to the fissurous condition. They have old vegetables in it, and it can differentiate because the silts usually have a dialenticity condition. What is dialenticity is something like this. If the moist sample is shaken in the hand, water is easily appear on the surface, and if it is squeezed in the finger, so water can disappear easily. Compared to clay, clay is very fond of water. It exhibit plasticity. It's readily molded when moist. So we can see something like this. And when left to dry, it can attain high strength. It actually has a flaky shape or needle shape just now, I mentioned just now. And it possesses large specific surface. So that's why clays are fond of water. And if you want to do further reading, you can read for clay minerals. So usually the montmorillonite clay has stronger or the one that much more stable compared to others. I think montmorillonite is much more the weakest clay soil, because our specific surface is highest, so there's a lot of water in it, easily to fail. Okay, so next, why soil is needed to be classified? What is the purpose to classify the soil? Why don't we just left the soil as it is and straightly use the soil? So, okay, classifying the soil is very important actually, because to estimate the engineering properties. By knowing the type of soil such as clay, silt, and sand, uh, as a main parent of the soil, it could also be sandy clay, silty sand, and so on. But by knowing the major properties of the soil, we can assess the strength and also can understand the condition of the soil. And by doing that, we can properly design the things that we want to do, like let's say tunnel, retaining wall, road embankment, and so on. And the most important things, all the classification activities allow us to communicate the same language with other engineers, the same language for other engineers, especially worldwide. So if you are talking about clay in Malaysia, is it is that the similar understanding of clay in UK? Is this a similar clay for Japan? So by doing this classification system, at least you have a general understanding for a similar soil type. Okay. So this is another example of why we want to have a soil classification. So once we understand the soil type, let's say type A, B, C, for this project, because we want to have a trench or something we want to build in it. If we know that the ground is rock, so we can design the slope, high to vertical ratio, and also their degree, the slope angle, as high as 90 degrees. So in type A, when we know that this is a quite good and stable soil, so we can have a slope angle as high as 53 degrees. And then follows for type B and also type C. So we can learn from here by knowing the type of the soil, so we can design effectively, and we also can choose more appropriate protective measures during before, during, and after the any construction that we want to have. Okay, so next, for the soil identification, especially in the field. So usually as an engineer, we do the we go to the site. So basically, when arriving the site, we already needs to have a visual examination, some of the checking to define the initial state of the soil. So we can do that by using different method. So knowing the particle sizes, measure their compactness, and check for their cohesion, plasticity, and also consistency. So besides looking for the ground color, the soil color, we also can do the visual examination by feel the soil. So if the soil is clearly recognized, so basically it has sizes more than 2 mm, so it's easily a gravel. So if has a gritty feel between the fingers, so it is sand, and follows all the criteria. So you can read more about this soil identification in your modules. But note that the organic soil have a darker in color, so it is a poor soil. So I think I stop here for this first part of this chapter. So until we meet again, in the next video. Assalamualaikum.